Well, hello again everybody. Now, as some of you will know who've been following my audio escapades, I've been having quite a lot of problems in trying to get a frequency response curve for the KR2600 receiver that I've been playing with. And you can see the problems that I was getting here. Now, a good amplifier should really have a good flat frequency response to cover the whole of the audio range. In fact, it should probably go well beyond that. As you can see by the graphs that we've been actually getting, they're far from flat. And I tried various things, went down various rabbit holes. I thought perhaps it could be something to do with the dummy loads that I was using. Maybe one was being slightly more inductive than the other. So this plot that we've got here is I'm not even sure which way around it is now, but one of them is using the ceramic resistors, which are quite low inductance, and the other waveform is using the I'm going to call them arcol resistors. They're basically a wire wound power resistors, which probably aren't particularly suitable for audio stuff because they are inductive, but I think for what I do they will be fine. I was grasping at straws as why I was getting this horrible frequency response, and by horrible I mean that at the mid-range where you would expect it to be flat, well, it is fairly flat there, but what it actually does as the frequency increases, the output goes up by, well, kind of almost a factor of 2 or 3, and as the frequency reduces from the mid-range, it goes up again. I didn't really understand why this was happening. I had no idea, and I tried messing around with the bias and checking various things, looking at the amplifier, and it turns out that it was just, I guess, well, you could call it a stupid mistake, but I'm guessing it probably wasn't a mistake in that it wasn't accidental. The problem was I just didn't know any better. So what the mistake was is that I had the loudness control switched on the amplifier, and as I always say, I don't know very much about audio equipment and amplifiers, and I've seen loudness buttons on amplifiers, but I've never really played with amplifiers, and I didn't know what the function of the loudness button was. But as a few of my subscribers have pointed out, Simon and also some chaps on the I think it was the Audio Karma website, that had I got the loudness button pushed in, had I got loudness selected, and you know, I had to go away and think about that because I don't know what loudness is. So the purpose of the loudness control is to boost the low frequencies and to boost the high frequency signals, but leave the mid-range quite unaffected. So let me just go to the other graph where we might see that a bit more clearly. So after I received this comment about the loudness control, I ran back upstairs, plugged everything back in, and lo and behold, I found that the loudness control was activated. Now, it wasn't particularly obvious on this amplifier. It's a push button, and you can really only tell it's pushed in when you actually toggle it in and out. It's not actually very obvious whether the loudness control is in or out. So the frequency response, if we actually have a look at it, it starting off at here at 10 Hz. It climbs slightly up to about 30 Hz there, where it really stays really pretty flat all the way to, what's that, 10 Hz, 20 Hz. It starts to roll off slightly about 20 Hz there. What's that, 10 Hz, 20 Hz. It starts to roll off slightly about 20 Hz there, but it's only rolling off very gradually. So if we go back to what kicked all this off, it was really about wanting to measure the frequency of the amplifier. And I can actually see on the original specification sheet, it says that the frequency response is between 20 Hz and 30 kHz. And I'm guessing that would be at the normal minus 3D point. That's where they're saying. Now, I'm not going to bother to plot that on here. It would be about, I don't know, well, it would be 0.7 of the peak, and we can actually see pretty much there that yeah, it would be within that all the way. So we can actually give a pass now to the frequency response test. I think we've achieved what we wanted to achieve. So here is the offending loudness control, which we can click in and out. But as I probably said earlier, although I've seen loudness controls on amplifiers, I didn't really understand what the purpose of it was. I mean, sometimes I've just pushed the button and gone, oh yeah, it sounds better. So I went away and then did some investigating, and I'm guessing the answer is a little bit interesting. Well, back in the 1930s, there was these two engineers called Fletcher and Munson. Now, these two engineers were working at a bell lab. And I guess in between working on bells, what they actually discovered is that depending on the frequency of the sound or tone that you listen to, the perception of the volume of that tone will be different. For example, if you listen to a 500 Hz tone and a 5 kHz tone, and you have both those tones at exactly the same amplitude, the 5 kHz tone will sound much louder. It will be perceived to be much louder. Now, in the same way, if you listen to the tone at 30 kHz, to actually sound as loud as it would be at 5 kHz, again, the volume would have to be much louder to have that same perception of sound. So the purpose of the loudness control, apparently, is to boost the low frequency and the high frequencies. Now, why would you want to do that? Well, the reason you may want to do that is if you're listening to your sound system at very low volume, the upper frequencies and the lower frequencies won't sound very loud. The music will sound, I guess, slightly distorted, coming back to the fact that us as human beings don't hear those low frequencies and the high frequencies quite so well. We don't perceive them so well. So somebody thought of boosting those high and low frequencies, and that's what was being demonstrated when we did the sweep of the amplifier. Well, I'd like to apologise in advance to any cats and dogs that might be watching. So I've set up the amplifier with an input from the signal generator of 5 kHz. So I'm going to turn the tone on now, and I've got that set to about 500 millivolts. Now, at the moment we've got the loudness control out. What we're going to now do is activate the loudness control. And as you can see, when I pressed in the loudness control, the voltage output did increase, but only by 150 millivolts or so. So it wasn't a massive change. Now remember, we're at the mid-range audio frequency now, and the loudness control is designed to boost the lower and higher frequencies. So let's just look at one of the lower frequencies. So we'll reset the signal generator to 100 Hz. Now we've got the same output voltage as the previous test, which is approximately 0.5 of a volt, and the loudness control is off at the moment, and I'm now going to press it in. And hopefully what we will see is that the gain of the amplifier will increase massively at the low frequency, because it's going to emphasize those low frequency signals. So here we go, I'm going to press it in now. And I will take it off again. So you could see there it went up from 0.5 volts to about 1.5, so it was 3 times bigger in terms of voltage gain anyway. And it would also do the same thing if perhaps we looked at the 5 kilohertz and then looked at 10 kilohertz. The 5 kilohertz frequency being in the mid-range would be unaffected by the loudness control, but the 10 kilohertz would be increased when we activated it. Well, I think that will do for now, but I will put a link to an article that I found on the web and that gives some really good information about the history of the Bell Lab and how Fletcher and Monroe did this research work in discovering the effects on human hearing. And it also gives some information, more detailed information about exactly how the loudness control operates and when it was first used in amplifier design. So go and have a look at that. It's a far better example than I can give you, seeing as I've just read about it today for the first time. As always, thanks for watching, and that'll do. Bye bye.